When we left off last time, we talked about beams and ribbons and sprites and colors and jittering positions and so much good stuff, and we made this like little rainbow zappy lightning strike particle system. And today we're going to be talking about how do we want to like change this on a per instance basis, because if we want to, instead of having this like scale color mess that we have here, say we just want it to be one color. For the most part, that's what like a lightning strike would be, right? Maybe we want to have a blue one and a green one and a red one and a purple one and so on and so forth. And are we really going to like use this one emitter and then make a separate system for red lightning and a separate system for blue lightning and a separate system for purple lightning and a separate system for pink lightning and so on and so forth? Because that might be the way you're thinking about right now, because that's how this works, right? You've got emitters, and you can put those into systems with like slightly different values. If you just want to change the value of like a pre-existing module, you don't need to make a separate system with an instance emitter for that. That is going to be a mess. That is where parameters come in. In the bottom left corner here, we have the parameters that Unreal Engine provides you by default. Things like the age, the loop delay, the execution state, whatever, how many loops you've done. We've got a bunch of things about the emitter, how old is the emitter, for the beam, the start, the end, the beam direction. A lot of information that you can use in all of your calculations over on the right hand side here, which I think will make a separate video just going into the more like complex calculations that you can do with all of the stuff on the right hand side as soon as we've gone over like this parameter thing. That is where things get really interesting and really important. So, and then we've got all the particle attributes. So this is on a per emitter basis, this is on a per particle basis, so the age of the particle, the color of every particle, and so on and so forth. Where it becomes interesting for this video is you can add user parameters. It's only supported in systems, not in the emitters themselves. So we've been working inside of this emitter this entire time. We're going to go over to the system version of it, which you can recognize by the fact that it has one of these little system nodes with it as well. And there you can see we can add user parameters. So let's add a user parameter here for the, actually let's apply the changes we made to this emitter so that the system will reflect that. And here we can say, I want to make the color. That's the example that I've been using, right? I want to make the color a parameter. So we can add a new parameter and then we can make new, and we've got a bunch of different types of parameters. And these are just variables for your particle system, right? So the common ones will be things like a bool, a float, integer 32, a linear color, a matrix, Niagara ID, whatever. All of these can be used to your discretion to do pretty much whatever you want, like a bool, for instance. If you want to add like just a tick box for a certain emitter, maybe to do a certain thing, like spawning certain particles at all or not, you can add a bool for that. Or the amount of distance that a particle needs to travel, or the velocity of particles on spawn or whatever, you can make a float parameter for that. The starting position, for instance, maybe you want to do something with that, or maybe it's the ending position of a beam, can be very easily changed. For now, what we're going to be doing is we're going to be adding a linear color, and this will be our beam color. And it is really as easy as now going into the color, and where we say, hey, linear color, and this is just a tint. We're going to just take this and drag it over, and we can just drag it over there. And now whatever we set this parameter to will be taken as the input for the color, as you can see right there. So that is a nice central way to influence some things about your particle system, but that's not where it ends, of course, because now if we pull this into the world, we can see we have this little like lightning strike, which will be very tiny. We also need to go into its emitter and set its loop duration to being the same as the particle's lifetime. That's quite important. So this is one of those things. We have two things that actually are linked to the exact same value here, right? So the loop duration should be the same as our particle's lifetime, which is in this case both 0.2 seconds. So instead of going back and forth and back and forth and back and forth and back and forth, what we can do is we might actually just be able to get the loop time from this actually. Yeah, I think we can just set the current loop duration in this case, and that will be fine. Just for argument's sake, what we can do is we can just make a new parameter, and we can say like loop lifetime, and set the default value there to like 0.2. And we can just use this user value in both of them. And then I can just change it over here whenever I want, and it will change both of them. Now, again, there might be something to the idea of just keeping the loop duration in here and then passing it through to the emitter. I also don't hate that idea, but for argument's sake, let's say that this is just easier to access. And now we can also change it very easily on an instance per instance basis. So as you can see now, it doesn't blink in and out of existence anymore. It just does as like wiggling. And we can see here, we have our beam color and our loop lifetime as user parameters that are exposed to the editor. So right here, we have both of them. And I can set the beam color to simply be like a magenta color. And now this specific instance will be a magenta color. And if I copy this over real quick and I said, actually, I want this one to be more red, we will be able to see that this one is now a more reddish orange color. They're still the exact same particle emitter, the same system. We didn't need to make a separate system for them. They're just separate instances using their own set of parameters. So for this one, I can also say, actually, I want this one to like live for 3 seconds, which means that you can see they like deform a lot more over that 3 second lifespan. Maybe I want it to be more chaotic. So I set this one to 0.1, which means that it wiggles around a little bit faster. So that's all well and good. And we can set these parameters to like a bunch of stuff, which is very, very fun. But now let's take a look at one thing that we have entirely ignored up until this point, and that is the emitter spawn. Because now that we have parameters, we can set those parameters on a per emitter basis, on a per instance basis, to use these parameters to set these values instead. So here we can set new or existing parameter directly. Here we can add our parameters that we have, so we can either make new parameters that are specific to this emitter. So if we want something to not be exposed like we just had, but we do want something to like get a random value or whatever, such as the color, we can make something that is only visible within this emitter and isn't an entire system-wide thing. So you can actually make that inside of the emitter itself. But we can also set a specific parameter, which is a lot of the parameters in the default engine we can access. Unfortunately though, you can't drag in your own user parameters. So if you want to have something be assigned like a random value per emitter, for instance, this isn't going to work because these values are here to be exposed to the end user. That is the point of this little window over here. So if you expose something to the user and then the actual particle emitter itself is going to mess with that, there's no real point in that for the most part. You can still use both of those things together to calculate a new output, which I will show you in a moment. But you can't directly overwrite these in set parameters. So instead, what you could do here is you could like make a new linear color. And that will be emitter linear color. We can change the name for that. So that is random color tint. And we will set that to a random linear color. Again, between this like blue cyan color and the like magenta color, or this red even. I'm going to pick a random color between those. So then in the actual color, we have our linear color for our beam. And we can multiply two linear colors together. So we've got our linear color and our scale factor in this case. The linear color that we're going to be multiplying with will be our parameter for random color tint, which is the value that the emitter itself generates on spawn. So in this case, that was this like quite nice blue looking color. And we're going to multiply that, setting our scale factor here to also be a vector 4 from a linear color. And that linear color is going to be our user defined parameter. So it's now going to be taking both of them. It's going to be a random one per emitter, but our user can still tint on top of that a little bit if we want to. So if we copy this one over, for instance, and we set this back to like a little bit more of a white color, we should see that it still has some color to it because, of course, getting a random color applied to it. But we can tint that a little bit. So if we tint that a little bit more toward yellow, that bluish color becomes green because they're getting multiplied together. And if I want to just say, actually, I want to overwrite this with my own color, making my own color like very saturated is effectively just going to override it. Still a little bit of that random color in there. Again, you could set up something where you also have a float value that lets you influence the amount that the initial like randomized color gets mixed in as well. You could set that to 0. Again, I think I should make a video more specifically about this type of thing. Taking multiple values together and using them together to do some like math to create more complex, more dynamic value. But before we do any of that, I want to show you one last thing, because these parameters, these user parameters, you can just set when spawning them in like this. But what if you spawn something in through code, right? If you have a blueprint and you spawn in a Niagara particle, or you even have a Niagara particle component, because that is something that you can do, how do we set parameters through code? Because that's probably something that you want to be able to do. So let's make an actor here, and we'll just call it new blueprint. That's fine. I'm going to put it right over here. Let's add a blueprint. It's a really weird way to add a blueprint, I am aware. And we're going to add a Niagara particle system component. We only have really one system that we care about, and that is this one. And it's getting this like very nice orange, almost pinkish color in this instance. But you'll see every time I compile this, actually, it reruns it again, or at least it should. I don't think it does. It will in actual gameplay. Doesn't do it in the viewport seemingly. But how can I set this beam color? Because I can set that in here now, and that is fine, and it will be more toward that color. It's good, that's fine. So that's not that difficult, right? But say we don't have it as a component. Now what do? Say we have on begin play instead, we spawn a Niagara system. Let's say we spawn it attached to this actor. The system template will be this system. And attached to components, we can just say we take our default scene route and we attach it to that. Location can all be the exact same thing, auto destroy, whatever, right? Then we get the output here as a variable, and we can just set a color parameter. Here we need to pass in the value of our parameter. So in this case, let's say that we're going to be making that like a bright green, and the parameter's name. And this is honestly just go back over into your system and rename, copy that name over and just paste it in, because this is case sensitive. This is sensitive to typos. You want to prevent weird issues because you just mistyped something, right? Now, if we have this specific actor here, it spawns in on begin play, and then we'll set its particle system to use the color green as we specified. So that is how you can set these values through code. And of course, we did it with a color in this case. You can set like a float parameter as well very easily, and every single type of parameter that you could be asking for, you can set through these means. So that's a little bit more about parameters. They really enable you to customize particle systems and make particle systems very customizable, so that you don't have to like replicate the exact same system a billion times over for very minute differences. Or in some cases, if you have a very like robustly set up emitter and system, even frankly, very complex particle systems can look very different using just different parameter inputs. You can do some really, really cool stuff. But in order to get anywhere close to that, I think we should just do a video, which we're going to do next time, about setting up more complex values. You've seen me using a couple of times the value from curve, and you've seen me like multiplying things a little bit. I think you should do a video specifically about just nesting those different things a couple of layers deep, so that we can get some really like deeper math going on to create cool looking systems. And for the full course, if you're watching this in the future, it should be all up on the YouTube channel already. But if you're watching this shortly after it was uploaded, there will be a link down below in the description to the Patreon where you can find the full course. And a very big thank you to all of my Patreons. You can see them on screen right now. If you want to help out supporting the channel, there's a link down below in the description to the Patreon page. A huge thank you to my Cave Student tier supporters, Earl Monseval Erno, and my Cave Digger tier supporters, Sir J. Thomas,